All right, in this lesson, we are going to talk about how to find inverses of cube root and square root, and then also cubic and quadratic. And so something you need to remember is to find the inverse function, you switch the x and y variable, and then resolve the equation for y. Graphically, a function is an inverse of another function if they are reflections across the y equals x line. So that'll be a way for us to check our work. Okay, so starting with this cubic function, I'm going to go ahead and graph it. It's been moved right 2 up 4, and so its inflection point is 2, 4. Okay, and so the original function, 2, 4. So 2, 4, and then because it's cubic, it's still going to have a slope of 1 on each side of the inflection point, but then we also have the other points going tall, okay? And so it kind of looks like a quadratic put together. Okay, so there's our original function, and then to find the inverse, we replace that f of x symbol with a y, and then we switch the x and y. Okay, and then now we need to resolve for y. So because we're solving for y, we need to isolate the cube. And so our first step is to subtract 4 from both sides. And then to undo a cube, we take the cube root. Okay, and so I am going to cube root both sides. The cube and the cube root cancel, leaving me with just a y minus 2 on the right side. And then we have the cube root of x minus 4 on the left. Last step, we just add 2 to both sides, and then make sure you don't add this 2 under the radical. You don't get to join the radical late, so it stays outside the radical. Okay, and so for our final answer for the inverse, we have a cube root. Make sure that 3 is small, x minus 4, and then outside the radical, a plus 2. Okay, and so for the inflection point, this is right 4, up 2. So 4, 2. Okay, notice this is the reverse of our original function. It should always be that way. All your x's and y's are switched for inverse functions. So to come over here and graph, I'm going to go to x equals 4, y equals 2. And then because this is cube root, we still have the slope of 1, but cube root looks like square root connected to an upside down square root. Cube root is like the short fat s. Cubic is the tall skinny s. Okay, and so if I draw the line y equals x, which is the slanted line through the origin, we can see that these are reflections across that line. Okay, this time we're starting with cube root, so I'm still going to find its inflection point. Its inflection point is right 1, so 1, but up 0, so 1, 0. And then we have a vertical stretch by 2. Okay, and so I'm going to start at 1, 0, and then that vertical stretch by 2 changes my slope from 1 to 2. So I go up 2 over 1, down 2 over 1. And because this is cube root, it looks like square root connected to a reflected square root. Okay, and so now to find the inverse algebraically, we are going to switch x and y. And then resolve for y. So our first step here is to get rid of the 2 outside. And so to keep it as a scale factor, instead of dividing by 2, I'm going to multiply by 1/2, which is the same thing. We just want to be able to see what the scale factor is. So 1/2 x equals the cube root of y minus 1. Now we're ready to get rid of the cube root by cubing both sides. And you could actually cube that 1/2, but I'm going to leave it in transformation form, so I'm just going to leave it just like that. And then our last step is to add 1 to both sides. Okay, and so our final answer is 1/2 x cubed plus 1. And this has only been moved up 1 with a horizontal stretch by 2. Okay, and so we're going to start with the inflection point, which would now be at 0, 1. And then to do the horizontal stretch by 2, our slope is now 1/2. So we're going to go up 1 over 2, and then down 1 back 2. Okay, and then this is cubic. So you have a parabola connected to another parabola for our shape. Okay, and so our original inflection point is 1, 0. And then my inverse inflection point is 0, 1. Okay, and so finding the inverse of cubic and cube root functions is simple because the functions are one-to-one, meaning they have the same shape. Okay, we're starting with an S, we're ending with an S, starting with an S, ending with an S. And so what's difficult about quadratic and square root is we don't have the same shape. And so these are not one-to-one functions, meaning the inverse actually isn't a function. So looking at this parabola, we can sketch the graph of its inverse. And the best way to do that is to make a table of points and then just switch all the x and y's for that point. So for my original function, I have the point -1, 0. I have the point 0, -3. I have the point 1, -4. I have the point 2, -3. And then I have the point 3, 0. I'm just going to use those points. That'll be enough for us. And then for the inverse function, we just switch all of the x's and y's. Okay, and so my y column is now going to appear on the x side. And then my x column is going to appear on the y side. So now when I regraph these points, I'm going to graph 0, -1, -3, 0, -4, 1, -3, 2, and then 0, 3. So if I connect these, it's a sideways parabola, which is not a function because it fails the vertical line test. You're seeing that we have a repeated x value of -3. X's can't repeat. And so this is not a function. So when it's asking what issue do we run into, the inverse is not a function. All right, so to counteract this issue, we add something that is called a domain restriction. So anytime your original function is a square root function, you must include a domain restriction on the inverse. Okay, so for example, if you are starting with a positive square root as your original function, you are going to end up with a quadratic. And so a positive square root looks like this. A quadratic looks like this. And so what you're going to do is restrict the domain to only be the right half. And so that way you are just getting rid of the extra part, and now our graphs have the same shape. Okay, if you are starting with a negative square root, you are going to end with a quadratic still, but you are going to restrict the domain to the left side of the quadratic. So you are starting with an upside down square root, you are going to end up with a left side of your quadratic. Okay, and then when you are starting with a quadratic function, if they give you a domain restriction, it's going to be the same idea. If it's a greater than, that means you have the right half, so you're going to pick the positive square root. If you're starting with a less than restriction, you're going to end up with a negative square root. Okay, so those go together. And then if they give you a quadratic with no restriction, you have to make sure to include the positive and negative square root. Okay, so our first two examples, our functions are square root. So the first thing we want to do is remember that we're going to have a domain restriction for square root for our final answer. So I'm going to go ahead and write a comma and then an X to start those domain restrictions. And so how you find the domain restriction is look at the range of your original function. So this is a square root function that's been moved right 3 up 1, and it's positive, so it's still upright. And so his range is greater than the 1. So his range is greater than or equal to 1. That means my domain for my inverse must be greater than or equal to 1. For this other example, it has been moved up 9, but it is reflected. Okay, and so our range is going to be less than or equal to that value of 9, which means my domain for my inverse is less than or equal to 9. So the pattern is if you have a less than or a negative square root, you're going to have a less than. If you have a positive square root, you're going to have a greater than restriction. And it always matches the range of the original function. Okay, and so I like to do that first because it's easy to forget once you start doing all the algebra. Okay, and so now to actually get the equation, we are going to do the same thing we did above. Switch your x and y. And then resolve the equation for y. So first step is isolate the square root. So we're going to subtract 1. And then now we need to get rid of that 1/2. So the way to get rid of 1/2 is to multiply both sides by 2. You can distribute the 2 or leave it outside the parentheses. I like to leave it. And then our last step, or our next step, is to get rid of the square root. Okay, and so we get rid of a square root by squaring both sides, including that 2 outside. And so I'd have double parentheses here. And then our last step is just to add the 3, and it stays outside of all of these parentheses. Okay, and so our final function has a parenthesis 2x minus 1 parentheses squared plus 3. And then we have that domain restriction. Okay, and then one other way to check your work is here the vertex would be right 1, and so our domain is greater than or equal to 1. So the vertex is 1, 3, because it's right 1 up 3. And then I said x is greater than or equal to 1. That means I have everything to the right of that vertex. So you can kind of picture what that would look like on the graph. Whereas our inverse function was a square root greater than or equal to the 1. 3, 1, 1, 3. Okay, for this next one, switch your x and y. First step, subtract the 9. And then we have this negative out front, and so technically you're dividing both sides by a -1. You can keep the negative outside the parenthesis. You can distribute it. I just like to leave the extra parentheses. And then now we are ready to square both sides. Okay, and so I have a negative x minus 9 squared equals just the 2x plus 6. Now we are ready to subtract 6 from both sides, leave it outside the parentheses. And then lastly, we're ready to get rid of this 2. And so we are dividing everything by 2. Oh, that x should have been a y. Okay, and so our final answer has negative x minus 9 squared minus 6 all over 2. There's ways you can simplify this, but I'm going to leave it like that. All right, number 3, we are starting with a quadratic with a domain restriction. Okay, so here for our final answer, we had a quadratic with a domain restriction. Our final answer was a quadratic with a domain restriction. Here we're starting with a quadratic with the domain restriction. So because we have the less than, that means we're going to have a negative square root for our final answer. Okay, and so just kind of keep in mind that you're going to have a negative square root. So same steps, switch your x and y. And then we are going to add 1 to both sides. Now to get rid of this square, we use our square root property, which remember we have a plus or minus for the square root. Okay, so I'm just gonna write the y plus 6 equals plus or minus the square root of x plus 1. Okay, as soon as you write that plus or minus, go see what your domain restriction is. If there isn't one, you need that plus or minus for your answer. We do have one, so we want to choose the negative. Okay, and so in this next step, I'm just going to write the negative. So now we subtract 6, make sure it doesn't go under the radical. So negative square root of x plus 1, then minus 6. Doesn't combine with the 1. That's a common mistake. Okay, so that is our final answer. Negative square root of x plus 1 minus 6. On a multiple choice test, both the positive square root of x plus 1 and the negative square root of x plus 1 are going to be options. So you really want to make sure you are choosing the correct one. Negative, because my domain restriction was less than. If it had been greater than, I would have chosen the positive. Okay, over here we have a cubic. Cubic and cube root are easy. There's no domain restrictions, nothing. You don't have to worry about plus or minus. Don't start adding plus or minus to these. As soon as you see a 3, those are easy. You don't do any of that mess. Okay, so I'm going to skip to 5 real quick because we do have a quadratic with no domain restriction. So that means we're going to have plus or minus square root for our answer. Okay, so switch x and y, add 5 to both sides, and then divide by 12. Or you could write it as 1/12 times x plus 5, either one. And then now we are ready for our square root property, plus or minus square root of x plus 5 over 12. Make sure that 12 is under the square root. And so plus or minus square root of x plus 5 over 12. Or if you wanted to, you could write that as 1/12 parentheses x plus 5 if you wanted it in transformation form. Okay, so don't forget your plus or minus because we did not have a domain restriction. All right, now for the easier ones with cube root and cubic. No plus or minuses, no domain restrictions. Just switch your x and y and solve. Okay, so our first step is to subtract 100. And then we need to get rid of the negative 5. And so I think I will write that as -1/5 times x minus 100. That just looks better. I don't like negatives in the denominator. Okay, now we're ready to cube root. Make sure all of the left-hand side is under that cube root. And then add 3 outside. Okay, so +3, +3, and cube root. Okay, and so your final answer, cube root of -1/5 x minus 100. And you could distribute that -1/5 again. So lots of different ways to write your final answer. If you don't see your answer written on a multiple choice test, just see if you could simplify it a different way. All right, last one, we're starting with cube root, so we're going to end with cubic. So x equals cube root of 2 times y plus 1, and then that +6 is outside the radical. Be careful. Outside the radical, but still all over the 3. Okay, so our first step here is to get rid of 3. We would multiply both sides by 3. So 3x equals cube root of 2 times the y plus 1 plus 6. Our next step is to subtract the 6 from both sides. And then we are ready to cube both sides. Now we are ready to divide both sides by 2. Okay, and so what we have so far is we have a 3x minus 6 cubed all over 2 equals the y plus 1. And so our last step is to just subtract the 1. Okay, and it's just going to be outside this fraction. So 3x minus 6 cubed over 2, and then minus 1. 3x minus 6 cubed over 2 minus 1. Okay, so for cubic and cube root, you don't have any domain restrictions, no plus or minus. If you're starting with square root, you end with quadratic with a domain restriction. If you're starting with quadratic, you're ending with square root. If you don't have a domain restriction, you have plus or minus. If you do have a domain restriction, less than leads to negative, greater than leads to positive.